Third property of matter was that the particles of matter attract each other. Now, how do we prove that the particles of matter attract each other? Simple. Take a look at these pieces of chalk here. This green chalk, blue chalk, yellow, orange and violet chalk. All of these chalk particles are rigid. They have a fixed shape, isn't it? A chalk looks like a chalk, and that's that. The chalk particles do not disperse into space, and spread everywhere on this earth. They are there in the form of a fixed and rigid chalk. This happens only because of the force of attraction between the chalk particles, and this tells us that the particles of chalk, or in general the particles of matter, attract each other. Take a look at these nails. These nails have such a fixed shape. As you can see, they are pointed at one end. There's this round part of the nail at the other end. Similarly, this glass, it's also fixed. It has a rigid shape which cannot easily be changed, isn't it? This glass has this shape no matter what, and this is possible only because the particles of glass and the particles of these nails, they attract each other, isn't it? Even water particles attract each other. Consider, this water which is flowing from the tap. You can see that the water flows in a straight line, isn't it? It feels like it's almost a rope of water, a rod of water, isn't it, which is coming out of this tap. That happens because the water particles attract each other. If the water particles did not attract each other, in that case, water particles would simply come out of the tap and move wherever they wanted to move, isn't it? They wouldn't stick to each other as they were flowing down from the tap. They are sticking to each other as they are flowing down from the tap only because there is force of attraction between the water particles. So here we go. Water particles attract each other, chalk particles attract each other, and nail or iron particles also attract each other. However, you must notice one thing here. The force of attraction between particles differs from substance to substance. As you can see, the force of attraction is very less in liquids. For example, the force of attraction in water particles is less than the force of attraction in chalk particles. When you put your hand underneath this flow of water, immediately, you can stop this flow of water, isn't it? You can break this chain of water particles by simply putting your hand under the tap. On the other hand, you can put your hand over the chalk, but definitely the force of attraction between the chalk particles is so strong that the chalk won't break, unlike the water cylinder which just broke when you put your hand under the tap. However, when you break the chalk with your hands, the chalk breaks, isn't it? So that means that the force of attraction between chalk particles is strong, but not very very strong. Because if it was very very strong, then the chalk shouldn't break, even when you're trying to break the chalk with your hands. Iron has particles which really attract each other a lot. That is because you cannot break those nails with your hands, isn't it? You can try and try, but no matter how hard you try, the nail will still be a nail. In fact, maybe it won't even bend. On the other hand, the chalk breaks, and the water layer simply can be broken by putting a hand underneath the water. So this tells us that the force of attraction in water particles is less than that of chalk particles, which is less than that of nail particles. So the force of attraction is different for different substances. So that was about the force of attraction between matter particles. Until now, we were studying about the properties of matter particles. Like the fact that their